Well, we have made it to the last lesson of Chapter 5. So 5.8 is going to be on parallel and perpendicular lines. So date there, and let's get started. So what we want to know about parallel lines, well, first, parallel lines, if you picture what they look like, these are two lines that will never cross. They look the same. So in terms of equation writing, what we're working on this chapter is parallel lines have the same slope. So they look the same, they have the same slope. It kind of makes sense. So anytime we're writing an equation for parallel lines, we just want to remember parallel lines will have the same slope. All right, if you have to determine whether or not two lines are parallel, if you're given the equation yourself, all you want to do is compare the slopes. We know what the slope is when it's in this form, y equals mx plus b, that's our slope-intercept form. The slope is the number with the x, so our slope is a negative 1/2. So we want to see, does the second equation have the same slope? Well, we don't know what the slope is when we look at this because it's not in slope-intercept form. So we want to go ahead and solve for y. First step is to subtract the x from both sides. So we have 2y equals negative x plus 6, and then divide everything by 2, and we get y equals, now this right here, this negative x over 2, that's like a negative 1x over 2. And so when we rewrite that, we can just write negative 1/2 x, and then 6 divided by 2 is 3. So again, we are comparing slopes. The slope of our second line is a negative 1/2. So are the slopes the same? Yes, they are. So these two lines are parallel to each other. So perpendicular lines, those do not look the same, so you're not going to have the same slope. Perpendicular lines will cross. If you have one line like that, the other one is going to cross it at a 90-degree angle. So that 90 degrees, that's more of something you guys will talk about in geometry. That is supposed to be a little symbol for 90 degrees. But what we can notice is if two lines are perpendicular, well, their slope will not be the same because they don't look the same. One line will have a positive slope, you'll have an uphill line, and another line will have a negative slope, downhill. So what do we have to remember about slopes of parallel lines? The slopes are opposite reciprocals of each other. So what we mean by opposite reciprocal, let me just show you a couple examples. If the slope is 2/3, the perpendicular slope, now the symbol for perpendicular is an upside down T. The perpendicular slope, we have to do two things to this 2/3. Reciprocal means flip your fraction, so we're going to flip it to 3/2. And then opposite means opposite sign. So if this is a positive 2/3, we want a negative 2/3. So those two slopes are perpendicular to each other. Let me just run through another example. If your slope is, let's say, 2, well, let's say negative 2. Your perpendicular slope, well, we want to do two things to that negative 2. If I make it a fraction that helps out, I want to flip the fraction, that's the reciprocal, and change the sign for the opposite. So if you flip that and change the sign, you get a positive 1/2. And those two slopes are perpendicular to each other. So are these two lines perpendicular that we have down here? Well, this one has a slope of negative 1/2. It's already in slope-intercept form, so we can identify that. This next one, we want to go ahead and solve for y. Get the x to the other side with addition or subtraction. So you have y equals 2x plus 6. All right, and then this slope is 2. So are these slopes opposite reciprocals of each other? Well, if you take one, the negative 1/2, if you flip it and change the sign, you do get a positive 2, or we could see that as a positive 2/1. So yes, those are perpendicular. All right, what we're going to be working on a lot in this section is writing equations of lines that are parallel to the line they gave us. So yes, these directions are kind of wordy, but you definitely want those in your notes so you can remember what this problem was asking us later when you study your notes. What they're saying is they give us this line, y equals 1/2 x plus 5. So I'll even separate it. We want to be parallel to that line. So think about, you got two parallel lines. Well, here's the equation of one of them. We have to write the equation of the other one over here. So when you see the word parallel, we have to say, what do we know about parallel lines? oh yeah, they have the same slope. So the slope of the line they gave us is 1/2. Now that's the only thing we need from that line they gave us. We just need to know what the slope is. For our new line, we're going to say, well, it's parallel, so we want to use the same slope of 1/2. And we're going to write our own equation with the same slope and this point, and that's going to give us a parallel line. So when we write equations, y minus y1, so y plus 3 equals our slope 1/2 times x minus x1. And then we will put these in slope-intercept form. So go ahead and distribute your slope. Y plus 3 equals 1/2 x. And then half of a -4 is -2. And then subtract 3. And we get y equals 1/2 x minus 5. That is a parallel line to the one they gave us. You can see that the slopes are the same, making these lines parallel. Alright, here's our last slide. This one, same directions. This time, instead of writing a parallel equation, we want a perpendicular equation. So again, I'll go ahead and separate the two. We want to be perpendicular to this line right here, which means we need to know what the slope is. Well, we don't know the slope if it's not in slope-intercept form, so we have to go ahead and solve this one for y. Carry down your -8y equals 2x plus 16. Divide everything by -8. And we get y equals, now this 2 over a -8, we can reduce that fraction. It'll reduce to a -1/4. The x just stays on the side. And then 16 divided by -8 is -2. Alright, so we did all that work to solve for y. Our reason for doing that is so that we could figure out what our slope is. So the slope of this line is a -1/4. Now, we don't want to use the same slope because we don't want to be parallel. This time we want to be perpendicular. So a perpendicular slope to this slope of -1/4, we have to do two things. Flip it and change the sign. So if you flip that and change the sign, you're going to end up with a +4. So now we'll write our own equation with the point 45, that's your x1 and y1, and a slope of 4. So it's going to look like y minus 5 equals 4 times x minus 4, that's our point slope form. To get it into slope-intercept, we distribute our slope. Y minus 5 equals 4x minus 16, and we add 5. Y equals 4x. -16 plus 5 is a -11. And that is our answer. That line is perpendicular to the line they gave us. The line they gave us has a slope of -1/4. This slope is its opposite reciprocal, +4.